Alright, so here we are with the 8-4 notes on significance of experimental results. Lovely. So the idea of these notes is talking about your hypothesis and testing, and the idea of these claims that people can make, but then if those claims are true. So very interesting moments here. So, first things first, let's suppose you flipped a coin 20 times. Even if the coin were fair, you would not necessarily get exactly 10 heads and 10 tails, even though that is what the theoretical probability explains should happen. But what if you got 15 heads and 5 tails, or 20 heads and no tails? You might start to think that the coin was not fair, because they make weighted things. So, our hypothesis testing is used to determine whether the difference in two groups is likely to be caused by chance. So the idea is that, is this potentially just that one time where, yes, in fact, everything turned up heads? Alright. So, for example, when tossing a coin 20 times, 11 heads and 9 tails is likely to occur if the coin is fair. But if you toss 19 heads and 1 tail, you could say it was not likely to be a fair coin. To understand why, you can calculate the number of possible ways each result could happen. There are 220 possible sequences of flips. So that was back when we were talking about our counting principle and things like that. And of these, how many fit the description 19 heads and 1 tails, and how many fit the description 11 heads and 9 tails? So this is rearranging kind of where these 9 tails could be versus one of them being tails. You can only kind of put it into one of the 20 places. So there are only 20 options. And this is actually, as much as this notation is lovely, this is actually going to be our, 20 choose 1. And then this is 20 choose 9. So we're looking at rearranging each of those and seeing how many ways that could happen. So clearly there are a lot more ways that you can rearrange things when they are different versus just that one difference in the 1 tails. So just a further explanation, since there are 167,960, so that was this part here, out of the 20 possible flips, there are 8,398 times as many sequences that fit the latter description, meaning this more common description, and they are more likely than the other one. Therefore, it is very likely that a coin that flipped 19 heads and only 1 tails was fair. So again, very unlikely that a coin flipped like that. However, that outcome, while unlikely, is still possible, so we did talk about that. Hypothesis testing cannot prove that a coin is unfair. It is still possible for a coin to come up with this 19 heads and 1 tails. It's just very unlikely. And so you can only say how likely or unlikely a coin is to be biased. And that's what we'll be looking at. So is this likely to be a biased or unbiased scenario? So, to figure that out, a researcher is testing whether a certain medication for raising glucose levels is more effective at a higher dose. In a random trial, fasting glucose levels of 5 patients being treated as a normal dose, Group A, and 5 patients were being treated at a high dose of Group B, were recorded in the glucose levels in MMO liters, I assume, moles per liter. Millimoles are shown below. Yeah, millimoles per liter. So we're going to state the null hypothesis for the experiment. So again, going back to the definition of our null hypothesis. Where is that? Oh, well, we didn't get it yet, so that's not going to be very helpful. The null hypothesis states that there is no difference between the two groups being tested. So the null hypothesis is that group A and B will have the same results. So again, basically, whatever it is that we set up won't actually make any difference. That's a null hypothesis. All right. So So continuing on, we're going to compare the results for the control group and the treatment group and ask ourselves, do we think that the researcher has enough evidence to reject the null hypothesis? So taking a look at each of these, all right, group A again was the one that had the normal dose, and then group B was the high dose. And if we look at our values here, 5.5, 5.1, 4.2, 5.9, let's see. Let's average them. And actually, instead of thinking of it as an average, we're actually going to do a number line. So the idea here, I guess we'll do it on one number line together. Alright, so the idea is that in the first one, the lowest number is 4.3. So that's about here. So this is group A. The highest is 5.7. 7 is here-ish. The median is going to be in the middle, so let's see, lowest, highest, second lowest, 4.8. Right there. And then, of course, the middle of each of those is the other numbers. So we've got 5.4 and 4.6. So 5.4, 1, 2, 3, 4. And 4.6. So that's group A. And then we're kind of trying to see if the distribution of the second group is the same or not. So the lowest value there is 4.2. Whoops, I'll do it down here a little bit. The highest number is 5.9. So hopefully you can see that that is a very close range. Then your median value is going to be 5.1. And so that is quite a bit further over than the previous one. And then we have 4.9 as the lower quartile. And then 5.5. Oops. Alright, so taking a look at that, hopefully you can see that they do kind of have the same spread. However, this first group kind of has a lower set of data, and this one actually has more of a higher set of data. So that's kind of saying that the group B that has the higher dose is going to have the higher level of glucose, versus the normal dose is going to be a lower. And if we know anything about glucose levels, we don't necessarily want super high glucose levels. And so what's actually kind of being seen is that that high dose increases the glucose levels, and therefore, now you're in that area of having more glucose than you need. And so the higher dose is actually less, has results that we don't necessarily want. So either way, and we now can say that we are going to reject, oh wait, we cannot reject the null hypothesis. And so this seems really weird because you're like, okay, wait, cannot reject. So that means that this null hypothesis of group A and B will have the same results. We cannot reject that. And so that means that we have the hypothesis. So we'll call it the conclusion hypothesis, that groups A and B do not have the same results. I did that wrong. Double negatives are not my friend. So if we cannot reject the null hypothesis, that means that we are accepting. So A and B don't necessarily have any difference. Yep, double negatives are not my friend. Okay, so your null hypothesis again, that's going to be asked of you, and it just states that there is no difference between the two groups being tested. And so when I wrote my null hypothesis, I said group A and B will have the same results, because nothing is going to change. The word null, of course, means 0, and so the null hypothesis is the difference between the two groups is 0. And so that's kind of where I get my null hypothesis statement. So this leads to a z-test, because basically there's a number that's involved with if you can actually accept this or not. So unlike looking at the data and kind of its spread like we did down here, we're actually going to be looking at a value itself and talking about if we can reject the null hypothesis with 95% certainty, or if there's not enough evidence to reject the null hypothesis, which means that we accept it. So in order to get this value, we have a few new symbols. X bar, up until now, has meant the mean, the sample mean, and so that's going to be featured. We also have this thing here, which is called mu. I know, it's weird, but that's a mu. And it represents the mean, but it represents the population mean, so the whole unit that we're talking about versus the sample that we just discovered, the smaller piece. Then we have our sigma here, which is your standard deviation, so that's going to need to be calculated or given. And then, of course, n, as usual, is the number of individuals in the sample. We do tend to want to have a large enough group, but if you don't have a large enough group, you can actually use this. It's just best if you can have at least 30 or more people in a trial or whatever you're working with, just so that you have a good set of data. So what happens is, whatever the digit is that you get this from, so subtracting those two means, and then dividing by the fraction of the standard deviation over the number of people square rooted. If that value in its absolute form is greater than 1.96, we're rejecting the null hypothesis, meaning that there is a difference. There is a difference. And then over here, if we have that z value in its absolute value and it's less than 1.97, we are going to say that there is not enough evidence to reject the null hypothesis, meaning there is not a difference between the two test groups. So this is these little words down here, very good thing to reference as we go through this. So we're going to try one using this z-test, or at least two of them it looks like. So the Same Test Prep Company claims that its private tutoring can boost scores to an average of 2,000 in a random sample of 49 students who were privately tutored. The average was 1,910 with a standard deviation of 150. So we do have this standard deviation, so we know that sigma is 150. We also know that our n value is 49. The random sample is going to be 1,910, and so that's going to be our x bar. But of course the company is claiming that its population mean is going to be represented by a mu of 2,000. So looking at our formula, what we're going to need to do is take our x bar minus our mu and divide by sigma over the square root of our number of people in this sample. So we've got our x bar of 1,910. We're going to subtract that with 2,000 and divide that by a sigma of 150 over a square root of 49. So if you do that, the best way to do it is to evaluate the top. So we get 1910 minus 2,000. which is leaving us with negative 90. And then that over 150 divided by the square root of 49. So 21.43. But if we take those two numbers and divide them, we get negative 4.2. And so because the absolute value of negative 4.2 is 4.2, and 4.2 is greater than 1.96, that means that we get to reject the null hypothesis. So we get to reject the fact that nothing happened. And so if we look at this, I crossed it out. That means there is a difference between the two groups being tested. So taking a look over here, the company can claim, can claim that their tutoring boosts scores. So again, we're rejecting the null hypothesis, meaning there is a difference. And so because there is a difference, the company can claim, they can state their claim that their tutoring boosts the scores of students over not taking their course. All right, and the next one is same idea. So they're telling us that standard deviation is 300 for a tax preparer claiming an average refund. The number of people in this is 40. The X bar, or the sample mean, let's see. You get 2600, and in the mu, so the actual population, they're saying it's 3,000. So to get our z value, we're going to take the X bar, which is 2600, subtract the average for the population, and take that over 300 divided by the square root of 40. So this one tells us that our z value, if we calculate it, is negative 8.4327. And of course that number, if you take the absolute value of it, is 8.4327, which is greater than 1.96, and because it's greater than 1.96, just as the previous one says, we're going to reject the null hypothesis, so we're going to reject that nothing happened. And so there is a difference. And so the idea is that the claim that this tax preparer increases your refund is true. All right, so that's fun. So basically you want to make sure that you understand this here, and if it is going to be an absolute value greater than 1.96 or not. And then this null hypothesis idea of nothing happening. And then therefore, if nothing happened, you can check to see if you can reject this nothing happening or accept it.